Okay, today we will discuss about the unbalanced fault analysis. We have discussed about symmetrical components and sequence networks. Okay, so just want to recap. Fault, we have three-phase fault or balanced fault. And then we have unbalanced fault. Unbalanced fault, we have single line to ground, line to line, and double line to ground fault. So today we try to cover single line to ground faults. But before we study about the fault, unbalanced fault, we have studied about the symmetrical component as well as sequence impedance, where we know already that for three-phase balance fault that you have learned in EPS, basically we transform the circuit into, or the system into, positive sequence impedance, right? And then we learn about negative sequence as well as zero sequence before we can go for unbalanced faults. Okay, so today we will look at how we want to analyze when the single line to ground fault. As I said previously, the main important thing is we want to find the fault current, IF. So we want to find the fault current. Normally the V pre-fault, we know already, normally given 1 per unit. So the important thing is we want to find the Z Thevenin or the equivalent impedance. Okay, but now since we have the single line to ground fault, so Z Thevenin for this system or this fault must be considered all the sequence. Okay, all the sequence. So later we show in details. Okay, most of the fault occurs in power system are unsymmetrical or unbalanced, and which results in unbalanced current flow. So that's why we learn about the symmetrical components. Okay, so it can be analyzed by using the method of symmetrical components to determine the fault currents and voltage of the system after the occurrences of the fault. So there are three major types: single line to ground fault, line to line fault, and double line to ground fault. Okay, so we have single line to ground fault, meaning that we have three-phase system: phase A, phase B, phase C. So single line to ground fault meaning that phase A short to ground, or phase B short to ground, or phase C short to ground. Line to line, phase A and B short together, or A and C, or B and C short together. So this one is, we call it line to line fault. And then double line to ground fault meaning that A, B short together and short to ground. So that is double line to ground fault. AC short together, short to ground, or BC short together, short to ground. So that one is double line to ground fault. And the severe one is the three-phase fault. Three-phase fault meaning that phase A, phase B, phase C short together and short to ground. So that's one is the severe one. But you have learned these things in your EPS, and we have discussed previous lecture. So let's take a look at how we want to derive the equation for the single line to ground fault. Basically, during your test or your exam, the equation will be given. So this one we want to discuss, or I want to derive how the equation is obtained. So the unloaded generator with a single line to ground fault. So basically we have simple unloaded generator. So the generator is, the connection of generator is Y type. Okay, Y, and then we have the neutral. So let's say for this analysis, we consider phase A as a reference. So let's say phase A short to ground here. And then when this line short to ground, what happened is, as we know, the currents, the properties of the current will be looking the shortest path to ground, right? That is the behavior of the current. So as you can see here, this one when it open is no current flow, but when it short to ground, all the currents is going to here. So meaning that all this current, even though you have IA, IB, and IC, so IB also, uh, all the currents, meaning that from here is going to ground. So that's why from here there is no current flow for IB as well as IC, because the current has shown or obtained the shortest path to ground. So that's why your when the fault current happen, when the fault occur here, your IB and IC equals to 0, because there is no current flow here, because all the current have flow to the ground here. Okay, and then when this happen, your IA is not IA is not 0, but your IA will become very very high, because uh, you have source the current here, but it's short to ground. So that's why when you do when there is short to ground, the current is quite high. Okay, and then from here we know already, because there is no voltage, no current flow. The current is going to here, so meaning that your VA is 0. Okay, so this one. So the general equation that will be used in the fault is this one. So you should remember, this one is 0 sequence, this one is positive, and this one is negative sequence. Okay. How to obtain this equation is by analysis this one. Oh, tak boleh masuk ni. Cuba masuk. wait for your friend. Tak boleh masuk juga. So now is 17. In your list of attendance is 13. So for those, check nama masing-masing. Check nama masing-masing. Kalau tak ada, you kena on your camera for a while. But dia nak capture. Now it's 13 already. Boleh tak? Yang dah ada nama tak apalah. Yang tak ada ni. Ni 20 tapi still 13. Okay. So basically, if you remember that our general equation okay, this is the general equation that will be used in the fault analysis. This one is a 0 sequence, this one is positive sequence, this one is negative sequence. If you expand this equation, basically you can get your VA 0 equals to, this one is 0, right? 0 times this one is 0 minus Z0 IA0, and then VA1 equals to EA minus IA1 Z1. VA2 equals to 0 or minus Z2 IA2. Yeah, we have discussed how to obtain this general equation. So this equation will be used. So in terms of matrix form, And then from here, from this knowledge or information, we can derive like this. Since we can use the symmetrical components that we have learned previously, you have the symmetrical components. You have the unbalanced current. This one, when the fault happen, that is becoming unbalanced, right? Because your IA you have value, but your IB and IC is 0. So this one you want to find the symmetrical components. So that's why you can get this one using the this equation. And remember, to find the symmetrical components, you need to do this one is A inverse, right? 1/3 A inverse times your current your unbalanced currents. So don't forget 1/3 here. And then the A inverse, you must remember this one. Okay. So when you do the expansion, you can get IA, IA0, IA0, IA1 and IA2 is equal. Okay, bila you kembangkan 1/3 dah IA1, and then the rest is 0, right? So this one pun tak guna sebab dah kosong. Meaning that now you get your IA0 sama dengan IA2 sama dengan IA1. So is IA3, IA/3, right? So, meaning that your your current, your unbalanced current divided by 3. And then this value, so you can put back into these equations. We know already IA0, IA1 and IA2. So you get to obtain this equation, because all the thing is equal, so you can put as a IA1, IA1, IA1 lah. Okay, guna ini. So but remember here, your VAO equals to IA1 Z0, right? This one is ini ya, IA1 Z0. So you can change the value there. So jadikan semua dalam bentuk IA1. This one IA1, IA1. And then we know already that our VA, the total voltage, your signal voltage is the summation of the positive, negative, and zero sequence, right? So you just add all these things. So you get this one EA minus IA1 Z1, IA1 Z2, IA1 Z0. And then we know already that VA is 0 since the fault happened at phase A. So you rearrange this equation, so you get this equation. So bring all these things to the here, because this one is 0. And then IA1 you factorize it. So finally you get IA1 equals to EA divided by Z1, Z2 plus Z0. Okay. And in order to find your IA is summation of IA0, IA1 and IA2, or you can say that is 3 times IA1. Okay, and then you can say here that IA is your fault current. IA is equal to I fault. Why? Because kat sini lah, because of the fault short to ground kan, so dia lah I fault juga. So what we can learn here is, in order to calculate the fault current for single line to ground fault, is you need to find the Z0, Z1 and Z2. Okay, so meaning that you need to find the positive sequence network, negative sequence network, and zero sequence network. Okay, so that is how it has been done. So this one is just the equivalent of 3 sequence network in series. Boleh tak? Boleh faham? Ke blur? Sekarang ni ada 15 saja dia capture. You check balik nama you all. Siapa yang tak ada? Siapa raise hand ni? Okey, ada soalan? Kalau tak ada, kita tengok contoh. Contoh dia itulah. Tapi saya tak suka contoh ni. Tak apalah, kita tengok contoh. Kita jawab cara kita lah. Cik Muhammad Asad. Dia kena buka kamera lah. Buka kamera kejap. Kita capture ni. Saya pun tak tahu. Okay, buat ada. Okay, ada dah. Okay. Alright. So we look at the example. 150 MVA, 13.8 kV Y connected synchronous generator has a synchronous negative and zero sequence reactance of 20%. (10% and 5% respectively. The neutral is grounded of the generator is solidly grounded, meaning that there is no ZN. Generator is connected to the short transmission line with a positive and negative sequence reactance of 10% and zero sequence impedance of 10%. The generator was unloaded when the single line to ground fault occurs on phase A. At the end of the line, find the fault currents at the voltage at the point of the generator terminals. Okay, so we have generator and have the generator. So first thing first, ialah you kena sketch lah. So we have 150 MVA, 13.8 kV. This one is positive sequence, negative sequence, zero sequence. Okay, and then you have a transmission line. Positive sequence dengan negative sequence sama 0.1, zero sequence 0.3. So apa yang perlu you buat sekarang? We need to transform into the positive sequence network, zero sequence network and negative sequence network kan. So since tidak ada transformer dan juga generator is simple, no grounded generator, so you can sketch positive sequence network. We have a generator, and then this is the impedance, and then we have bus, and then we have the transmission line is open, but this one is short to ground. Okay, so you have 150 MVA. Senang ni, 13.8 kV, and then positive sequence 0.2. So this one is J 0.2. And then your transmission line, positive negative sequence 0.1. So this one is J 0.1. So from here you can find Z1, that Thevenin, right? Z1. Look here, it's just a series. So your Z1 equals to J 0.3 per unit. So soalan senang, tidak ada tukar value, tidak ada tukar base. And then you go for the negative sequence. Negative sequence sama, cuma tidak ada source. So 10%, J 0.1. And then this one sama, J 0.1. So Z2 is J 0.3. 2 per unit. And then zero sequence. Your zero sequence, you need to look at the connection. Since Y connected to ground, so normally tidak ada masalah. And so you just put here. And then your transmission line also similar. There is no change of the value or per unit value. And then 5%, 30%. So one is J 0.05, J 0.3. So your Z0 equals to J 0.35. So from here, we just apply our equation, find the fault current. Fault current is 3 times EA, right? So EA normally in terms of per unit, normally is 1 per unit. Okay. So 3 times EA or 3 times EA, we would divide by Z0 plus Z1 plus Z2. Okay. So it is 3 divided by J 0.3 plus J 0.2 plus J 0.35. Berkira berapa dapat? Dia dapat kan? So you dapat minus J 1.76 minus J 1.76 per unit. So in my class, my practice, if you calculate until here, I give you full marks. Except the question asks you to calculate in ampere. If you just calculate the fault current, you just calculate until per unit is okay. So pada saya, you boleh stop kat sini lah. Atau you kena cari kena darat 3 kan? Atas tu darat 3 lupa. 1. So 3 darat tu ialah fault current ialah 3.528. Tak darat 3 ni. So 3.528 lah. So I fault ialah negative J 3.528. 528 per unit. Okay, this is your fault current. Kalau you nak kira in terms of ampere, you kena cari base for current. So saya tak galakkan buat depan sama sini lah. Kalau you nak cari dalam current dalam ampere, you just cari you punya base, guna equation ni. I base equals to this one your MVA, right? MVA divided by square root 3 darab dengan kV. So you dapat you punya I base 6276 ampere, and then you darabkan dengan 3 dapat 22,000 ampere. So jawapan pada saya, you jawab sampai sini pun dah okay. Okay, buat soalan suruh find the fault current. Okay, so your fault current in per unit is okay already. So ada soalan? Ada soalan kelas? Okay, kalau tak ada kita tengok contoh. Okay, tengok contohnya. Okay, soalan biasa memang panjang-panjang macam ni. So until here basically you can do soalan A dengan B kan. Okay, let's take a look at this example. A 3-phase 50 MVA, 11 kV, this one. Alternator having 50% reactance, 0.15 per unit, is connected to a 50 MVA ada transformer. 11 kV, step up to 33 kV. So 11 step up to 33 kV. Delta star, connected to transformer of 5%, so 0.05. And then having a negligible resistance at the rated of 4 ohms. Kat sini you punya transmission line, basically 4 ohms. At the receiving end of the line, there is a 50 MVA 33 kV to step down to 11 kV. Delta star connected, so delta star connected. Transformer of 5%, sama. Basically, this is a similar type of the transformer. Stepping down at the voltage to the voltage 11 kV. Both transformer have the neutral solidly earth, meaning that there is no ZN. Okay, solidly earth, meaning that there is no ZN. Basically, this one is supposed to be Y grounded. Draw the one-line diagram of the positive, negative, zero sequence networks of this system and determine the fault currents for the following type of fault at the receiving session low voltage bus bar. Here, short to ground. So you need to find the fault current. So soalan A, you need to find the three-phase fault. Soalan B, you need to find single line to ground fault. Yang ni tak payah buat lagi. For generator, assume negative sequence reactance of 70% of that positive sequence. Zero sequence bagi tak? Generator, assume negative sequence. Tak boleh tengok tak depan dia. So dia tak bagi, maknanya tidak ada lah. Okay, never mind. Soalan ni agak tricky sebab dia biasa bagi, ni tak bagi. Okay, so first thing first, you need to what? You need to do the positive sequence, negative sequence, and zero sequence. But you need to ensure that all the components are in the same base. So, luckily the base is similar for generator, for transformer. Okay, so 50 MVA, so we just use the 50 MVA. So meaning that there is no voltage changing lah, ataupun there is no value change for the positive and negative sequence, right? Okay, so here is 11 kV, step up to 30 kV, so step down back to 11 kV. So there's no trick there, but you have the transmission line in terms of ohms. So from here, basically what you need to do is you need to find the Z base at your transmission line. So Z base equal to what? The equation of Z base kena ingat kV square divided by MVA. So 33 kV square divided by 50 MVA. Berapa dapat? Kita kira 33,000 square divided by 50 MVA. So you get your Z base equals to 21.78 ohms. Okay, correct. So next you can calculate ni tak tahu. Ni tak payah buat pun tak apa sebab kita ni tidak ada value, right? Apa? So next is you just sketch your positive, negative and zero sequence. So positive sequence, this is a positive sequence. Generator, short to ground. J0.15, and then you have transformer J0.05, and then you have transmission line. So 4 ohms divided by berapa tadi? 2178 berapa dapat? Bagi 21.78. So transmission line is okay, J01837. So here J0.1837, and then your transformer J0.05, and then this one is short, right? Short to ground. So this is positive sequence. So from here you can find your positive sequence is just a series. Betul tak? Ditambah je semua ni. Z1 equals to berapa? Tambah sebab ada series saja. 0.1 tambah 0.15. 0.4337 per unit. Salah ni cara kerja ni. Transmission line, mana transmission line? Transmission line. YZ1 dia. Kenapa bagus 0.444? Silap ni. Salah. Tak, tangent X1 2.42. Oh, soalan ni saya nak buat lah. Kenapa dia jadi gitu? Subtransient X1 0.15 per unit 0.363 ohms. Pelik pula. 2541. Positif, negatif, zero sequence sama. Z base 01.021 ohms. For transmission line, return 4 ohms at 50 kV, 11 kV. 444. Dapat 4337, right? Oh, soalan ni salah lah. Never mind lah, kita skip lah soalan ni. So saya takkan bagi soalan macam ni lah. Very tricky. It's very tricky because it's very short of information. That's why they make a assumption. So because they didn't give the zero sequence, right? 3-phase 11 kV 15 reactance is connected 50 MVA. Delta star connected transformer 5%. Negligible resistance reactant of 4%. 4 ohms. At the receiving end 50. Both transformer had neutral solidly earth. Draw this 1 diagram. Positive, negative, zero sequence networks for the following types of faults. So basically it's just make assumption based on this. So normally soalan saya tak bagi macam ni lah. But it can be interesting. Maknanya depan ni saya boleh cuba macam ni. Okay, never mind, we skip this thing because dia agak tricky. Mari kita check soalan lain lah. Let's take a look at the example of last semester. Test tak ada quiz lah. Ini senang lah dari dah. Tengok soalan final lah kita. Let's take a look at the example of final. Soalan final. Ni last 2 semesters. Okay, let's take a look at this example. Kita dah discuss itu kan. Okay, tengok ni ya. Okay, so let's take a look at this example. Okay, 6 bus power system network electricity company shown in figure 3. The positive and zero sequence reactance of line transformer per unit 100 MVA are MVA base are tabulated in table 3. Data Y transformer between 3 and 5 is grounded through a reactor of reactance 0.1 per unit. The generator's positive and zero sequence reactances, including the reactance of grounding neutral 100 MVA, tabulated in table 4. Assume positive sequence impedance and negative sequence impedance are same. Fault occurs at middle of transmission line 5 and 6. Conduct the analysis, fault analysis. So meaning that if the question is conduct the fault analysis, meaning that you need to calculate all faults, all type of faults. Okay, you need to calculate positive single line to ground fault, double line to ground fault, line to line fault, and as well as three-phase faults. Yeah. Okay, so let's take a look at these questions. So we have 1, 2, 3, 4, 5, 6 bus. So basically what we need to do is you need to sketch. Dan soalannya agak mudah sebab you tak perlu tukar base. Boleh tak? Kita tengok soalan ni. Bukan soalan ni, soalan ni. So from here you can sketch. You can sketch for positive sequence, generator, bus 1, and then you have transmission line here. This one is bus 6, bus 1, bus 6. This one transmission line. You have this one is bus 4, and then you have transformer, and then you have bus 2, then you have generator. Okay, and then you have this transmission line. This one is bus 5. You have transformer. You have bus 3. You have generator, and then you have ground. Okay, kalau tinggal gini je tak ada masalah, kena letak value. So kat sini you boleh tengok, you boleh masukkan value. Okay, so this one is transmission data. Okay, so 1 to 6 0.215, 1 ke 6, J 0.215, So don't make mistake biasa student tend to make mistake when they transfer the information into the bila you sketch tu. Tu bar 1 ke 6, 2 ke 4, 2 4 mana 4? 2 4 yang ni. 0.035 and then 35 yang ni. 35 ni basically transformer lah. Tak apa, walaupun dia kata gitu, data lines for transformer, okay. 35 0.042 0.042 then 46 125 then 56. Mana 56? Oh ni, 56 175. Okay, this is positive sequence and then you put back all the value of generators. 1 0.2 2 0.15 0.25. This one G1 0.2 G3 0.15 kan, G2 1525 G 0.25. Okay, so this is positive sequence. So basically positive sequence dengan negative sequence sama. Cuma yang beza dia ialah negative sequence you kena sketch juga. Negative sequence tak ada source. Tak ada lah. Tak ada, ni tak ada, ni tak ada. Yang lain semua sama. So next, you need to find what? What you need to do is you need to find your fault happen dekat tengah-tengah sini kan. Sini. So you kena tengok pandangan sini ya. So ni 1.75 ni mana you kena bagi 2 lah. Saya rasa ramai salah ni. Majority salah kot. 175 you bagi 2, 0.0875 kan. Sebab dia bagi 2. So berlaku kat tengah-tengah transmission line. 0.0875. Sini pun 0.0875. Okay. So kita boleh analyze apa yang you boleh tengok kat sini. You boleh groupkan pandangan sini dia cabang kan. Dia bercabang maknanya kita boleh panggil dia A. Kemudian yang ini dia ada titik cabang lagi. So ini ialah B. Dan yang ketiga ini cabang. So ini ialah C. So you boleh dapat Z1 ialah ni cabang kan. Okay, tak apa. So A dia akan parallel dengan yang ini J 0.0875 sebab ni dia cabang tapi dia sebenarnya dia bila dah parallel dia tambah kan. Betul tak? Buat sini lah. So Z1 equals to A parallel dengan J 0.0875 tambah but yang ini bila cabang dia akan jadi series. So B parallel dengan C. Betul tak? You tengok sini cabang, bila cabang dia parallel. Kemudian yang ini dia parallel dengan yang ini sebabnya separuh transmission line. Kemudian dia ni dengan ini sebenarnya series tapi yang ini cabang. Betul tak? So series kita tambah, cabang kita parallelkan. So A you carilah A berapa? A berapa? Cuba kira. A 0.0875 tambah 0.042 tambah 0.25. So your A ialah Z 0.3795. B berapa B? B 0.4. 0.4 2, 0.2, 415. C tambah ni semua ni berapa ni? C 0.15 tambah 0.035 tambah 0.125. So C ialah J 0.31. Okay, so you boleh calculate using your calculator. Your A J 0.3795 parallel dengan J 0.0875 tambah B 0.41575 dia 415 415 parallel dengan C 0.31 J 0.31 parallelkan tambah parallelkan balik. So dapat jawapan. Cuba buat. Okay, so that one is the positive sequence, and luckily your negative sequence is similar with the positive sequence. So you just sketch your positive negative sequence, ataupun you malah nak sketch, you just stated that the value yang dapat ni Z1 equals to Z2 and then berapa. So that is your solution. Next, we want to find the zero sequence. So zero sequence is quite tricky. Why? Because of zero sequence you kena buat connection Y ni. Betul tak? So kita start kat sini ya. This one generator grounded, tak ada masalah. It's just grounded. And then bus 1 and then transmission line ni bus 6 and then dia cabang dengan bus 4 and then ada Y kan, Y to data. So macam mana Y to data? Y dia akan ground kan, data akan open, and then you ada G2 and then ada ZN lagi. Okay, next ni bus 6 ni bus 5 ada transmission line masuk dekat transformer ada ground data. Ni ada tricky. Yang ni Y grounded kan, ni Y ada ZN. So Y dan ZN and then data ni akan open and then you ada generator 3. Itu saja. Boleh? Tak nak confuse, letak nombor. Ni nombor 1, bus 1, ni bus 6, ni bus 4, ni bus 2, sini tadi, ni bus 2, dan ni bus 5, ni bus 3. Boleh? So kemudian you masukkan value lah. Cuma kat sini ada trik sikit, you kena tengok, tak ada trik just 0.1 kan. 0.1 transformer Y data bus 3 to 5 grounded to reactor 0.1 per unit. Okay, 3 to 5 yang ni 0.1 per unit ada ZN. ZN remember you kena darab dengan 3. Ini pun biasa student silap. So 3 ni ZN kan, equals to J 0.1 darab 3. Okay, and then transformer punya information dekat zero sequence ambil yang ni. Tapi dekat generator 2 ada XN neutral 0.05. Generator 2 ada sini ada 0.05, so maknanya dia 3 J 0.05 darab 3. Jangan tinggal. And then itu saja. And then 0.06 generator 1 here is J 0.06. Generator 2 0.04. So right, 0.04 dan 0.08. So 0.04. Generator 2 mana? Ni buat 3 ni 0.04. J 0.04. 0.08. Generator 3 0.08. Here. J 0.08. Then you connect all the connection transmission line. 16.0.39 16.0.39. Then 24 transformer 0.035. Ni J 0.035. Kemudian 35 transformer juga 0.042. J 0.042. Dan 46 mana 46 yang ni 46 0.25. J 0.25. And then 56 035. J 0.35. Okay, and then sampai sini boleh? Boleh tak kelas?
Boleh sir.
Boleh lah. Kita kena cuba buat lah. So sekarang ni fault dekat bus transmission line 56. Mana tadi? Ni lah. Fault dekat sini. So fault tu bagi hitam lah. Okay, fault dekat tengah-tengah ni 56 sini lah. So maknanya ni ialah 0.35 bagi 2 0.175, right? So sebelah sini ialah J 0.175. Sini 0.175. So kat sini pun you boleh tengok cara kita nak jawab sama macam tadi, cuma mudah sikit sebab ada yang grounded tu kan, open. So dia ialah pandangan daripada titik fault ini bercabang. Betul tak? So ini bercabang. So ini ialah satu line ni. Kita boleh bagi nama X. And then dia cabang ni satu macam tadi lah. Ni cabang lagi. So ini ialah Y. And then ni cabang sampai sini je kan. Ni open. So ni ialah Z. So your X, your Z kosong equivalent equals to ni kan, ni cabang ni kan. So dia ialah X parallel dengan J 0.175 ni tambah sebab dia cabang kan, tambah dengan Y parallel dengan Z. Okay, macam tu lah. So buat balik dapat jawapan Z kosong. So then you dapat Z kosong, Z1, Z2. You can calculate your three-phase fault. Three-phase fault tak ada masalah. Because three-phase fault ialah you refer pada Z1 only. Betul tak? So V bagi dengan Z1. And then single line to ground fault. 3 darab dengan EA 1. So 3 bagi 1 darab dengan Z1 tambah Z2 tambah Z0. Okay. And then yang lain tu kita akan tengok next. Ada soalan? So as you can see here, it's quite messy here, but hopefully you can understand. So video ni saya akan upload dekat YouTube, so you boleh tengok ulang-ulang lah. Kalau saya ada buat salah, you boleh bertegur lah. Tapi saya tak ada salah. Make sure lah you understand. Kalau jawapan bila you sketch tu, that's why nama dia sketch. You need to, saya tak suka buat cara macam you tukar dalam macam tadi kan, ni kan, you cari common ground. Saya tak suka cara tu. You buat benda sama je, bentuk sama. Bila ground, dia ground lah. Okay, so it's ground. So dari situ you boleh analyse, you boleh nampak. Dan saya rasa soalan ni 1 atau 2 orang saja yang betul. Last 2 semester lah, 19-20. Sebab saya kata dekat tengah-tengah line ni dia tak bagi 2. So dia kena bagi 2 sebenarnya. Boleh? Sebab dalam kelas biasa saya tunjuk contoh fault happen dekat bus. Bila saya kata dekat transmission line, dia tak tahu nak buat macam mana. Boleh? Mudah tak? So from here you can see saya boleh buat soalan macam-macam. Yang paling penting sekali ialah fundamental circuit theory. Dia sebenarnya circuit theory ni. This one is just a circuit theory. Sebenarnya dia ialah untuk cari equivalent impedance saja. Kalau you belajar dulu, benda yang pertama sekali you belajar ialah cari equivalent impedance kan, ataupun equivalent resistance. Okay, itu dia sebenarnya. Bila dapat tu nak kira fault, sebab pre-fault voltage normally is 1 per unit. So yang lain tu you kena ikut equation lah. Equation diberi. Tak percaya tengok soalan ni. Equation diberi. Okay. This one is line to line fault. This one is three phase fault. This one is single line to ground fault. Ada beza sikit dengan apa yang saya tunjuk tadi. Beza dia ialah ni lah, ZF ni. Soalan ni tak ada bagi ZF, maknanya kosong lah. Kalau dia kata fault current, fault happen here and there is an impedance for the fault berapa? Baru you tambah. Ni question dia. Okay, 3 VG maknanya 3 pre-fault voltage dibatkan Z0 plus Z1 plus Z2. So that's why saya kata equation diberi, tapi sebenarnya cara yang penting ialah macam mana you nak faham. You nak faham fundamental. Maka banyak dekat you construct the circuit. Maka untuk kira fault ni dalam 1 atau 2 markah saja. Sebab you boleh guna equation. Boleh? Ada soalan? You kena cuba. Boleh So tak ada soalan So tak ada soalan, we stop here. Later I will share with the video. So next week your test, don't forget 8 to 9:30. So saya bagi buffer half an hour sampai pukul 10 you boleh submit. Tapi kalau you submit lambat pun you submit je lah, sebab saya tidur pukul 9.30. Maknanya you habis test tu, kalau you message saya buat tak tahulah. And then next week Monday kita akan cuba buat some revision lah before your test. But weekend ni you kena study lah. Boleh?
Boleh sir.
Okay, I think that's all for today. Thank you for your attention. Hopefully you can understand. So see you next week. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.